Hey everyone, welcome back. I'm excited to announce that Yuyong Industry sent me one of their QueenAnt Pro machines to do a full build series on. In this video, I will go over the mechanical build, then following this, we'll get into the wiring and configuration of the offline controller with closed loop steppers. So let's get into it. We can start by building our X-axis rails. For this, we need our rails and the hardware listed on screen. I like to thread my sliding T-nuts one turn onto my screws and then slide the whole rail into the extrusion at once. So for a 1010 machine, this comes to 16 screws and 16 T-nuts for each rail. Once that's done, on the open side of the C-beam, slide them into the endmost slots. You might need to use a finger to rotate the nuts as you do this, but the process is pretty easy. When you get to the end, just tighten down the last T-nut so that it can't slide out while you're working on it. Now repeat the same steps for the other rail. Now we'll use our included linear rail guides to line up one rail. The second we'll leave as it will be aligned by the gantry. Start by loosening any of the screws you had tightened on the bottom rail. Place your guides onto the linear rail. Sometimes they will snap into place, other times it might need to be held. Starting in the middle, pinch the linear rail into the guide and then tighten the screw. Now do this at both ends. Lastly, use one of the guides to work your way through the rest of the screws to make sure that they're all aligned. Once you're done, remove the guides and make sure you have left the end screws on your top rail tight so that it can't slide out while being moved. Now set that aside and let's get our X gantry ready. With the parts listed on the screen, we can start by installing our ball screw nut housing. One side has M5 tapped holes in it, so line these holes up with the ball screw nut and slide it over the rail. Go ahead and get all 6 screws started and then tighten them down. Rotate the ball screw so that the nut is on the left-hand side of the housing. Then place your X gantry plate onto the nut housing and thread the M5 14mm screws in. Tighten these down all the way and then loosen them by half a turn. Okay, now onto an important step. When rails, bearings, ball screws, and some other components ship, they are often coated in an oil to make sure they don't corrode while they are being stored. This is not the best lubricant for these, and it's a good idea to clean it out. My method for cleaning a linear bearing is simple. I submerge it in IPA and use a screwdriver or paintbrush to cycle the bearings through a few times. You will see lots of dirt coming out when you do this. The HDR 15 blocks have bearings on the top and bottom on both sides, so take your time to run through all of them. Once done, lay the bearing block somewhere to dry. Take care when doing this so as to not pop a ball out of the bearing. If you do, you can simply pop it back into place. Once you're done, if you're not going to use the grease nipples, re-grease the bearings now with some white lithium grease. Back to our X-rail. With the bearings retainers still installed, slide 2 bearings onto each rail, letting the retainer drop only once the rail has taken its position. If you're using grease nipples, make sure they are facing outwards now. Now take your X-axis gantry assembly and your X-axis rail assembly and place your spacer blocks onto the bearings. These are here to give room for the ball screw. Roughly work out the spacing of the holes and then place your gantry assembly on top, lining up the 4 sets of holes. Now slide your 16 M4 32mm screws in and loosely thread all of them. Once you have threaded them all, you can go ahead and tighten them all down. Now to align the top rail, loosen the end screws on the rail, then slide the gantry to one end, making sure you do not go past the end of the rail as you could lose a ball bearing. Then proceed to tighten the screw closest to the gantry. Work your way through all the screws while sliding the gantry to make sure it's as close to alignment as you can. Once this is complete, the gantry should slide freely and easily from a push. Setting that aside, we can build our Y-axis rails. Using the same steps as before, prepare your rails. Then slide them into your C-beam and tighten one side using your linear rail guides. Now repeat this one more time for the second Y rail and set them aside. Onto our Y gantries. Again, a very similar process to the X gantry. Place the ball screw bearing nut housing over the ball screw and thread the 6 M5 15mm screws and tighten. Rotate so the block is on the right for the left-hand Y plate. Then place the plate on top and thread the 4 M5 14mm screws. Tighten them down all the way, then loosen them by half a turn. Let's install our linear bearings onto the Y rails we prepared, sliding them on and letting the retainer drop. Make sure that if you're using grease nipples, they are facing outwards. Once this is done, space your linear bearings roughly lined up and place your spacer blocks on top. Now put the Y-axis gantry with ball screw on top and thread the 16 M4 32mm screws through into the bearings and tighten them down all the way. Just like we did with the X-axis, we are going to loosen the end screws on the top rail and move the gantry to the end. Then proceed to tighten the top rail down, bringing it into alignment with the bottom rail. Again, we should not have binding and the gantry should move back and forth with a push. If this is not the case, you need to spend some time trying to find where the binding is happening, as it will cause issues down the road. Repeat the same process again for the other Y-axis gantry. However, now the ball screw will be rotated so the block is on the left-hand side. Let's add our L brackets to the bottom of the Y-axis. We are going to need to measure our equal distance based on the size of our machine, so make markings with a pencil on your C-beam to divide them into quarters. Deduct 10mm from the measurement, as this will make our 20x40 extrusion centered on these points. For a 1010 machine, this works out to 245mm, 490mm, and 735mm. Try to make these as accurate as you can, as it will help with squaring your machine. Go ahead and slide 8 T-nuts into each slot on the bottom of the Y rails. Now, using the M5 screws, place an L bracket facing outwards from the end of the machine. When installing the L brackets, one end has the holes centered on it and the other has them offset. Make sure the offset end is what you are placing against the rail. The centered holes will be used for the 2040 extrusion we install next. The next L bracket will be in the reverse direction, and so on and so forth until all 8 are installed. Leave roughly 20mm gap, but a little extra is fine. We will adjust these later. Now align the left-hand bracket with the marking we made earlier and loosely tighten it down. Go ahead and repeat this for the rest of the brackets. Again, we need to repeat the exact same steps on the other Y-axis assembly. Keeping your measurements accurate here will help with the squareness of the machine, so pay attention. Setting these aside, let's finish with our X-axis rails. We are adding some supports to the rails to help with twisting. For this, we will install a 20x40 to the back of the rail. Start by sliding 5 T-nuts into the top slot, then install the 90-degree brackets on each using M5 8mm screws. Now repeat the same steps on the bottom slot of the rail. Now mark your 20x40 extrusion to evenly spread the 90-degree brackets again. Deduct the 10mm from the center points. So again, the 1010 machine, this will be 245mm, 490 and 735mm. Then slide 3 T-nuts into the top and bottom slots of the 20x40 extrusion. Now place the 20x40 extrusion onto the C-beam in between the 90-degree brackets you just installed. Go through each 90-degree connector and thread your M5 8mm screws into the corresponding T-nuts. Now align them with your markings and tighten them down with both screws. The two end 90-degree brackets should be left facing the ends of the extrusion, as they will be used when we install the X-rail onto the Y gantry plates. Flipping the X-rail over, we are going to install 2 more 90-degree connectors on each end, facing the ends of the extrusion. Now take another one of your 20x40 extrusions that is the same length as your C-beam and slide it inside your C-beam. The X-rail assembly is now ready to be joined with the Y-axis plates. This can be a bit heavy to hold on and align at the same time, so you can prop yours up or get someone to help. I like to roll my Y-axis onto its side while holding the X-rail while getting one screw started. This will free up your hands to then align things the rest of the way. Thread all 10 M5 screws through their respective aluminium extrusion. You might need to hold your 20x40 extrusion so that it does not slide away from the screw while doing this. Once you have them all in, tighten them down. Over to the other side of the machine, install the second Y assembly the same way. You will need to slide the ball screw into the bearing as you do this. If you're having issues getting it to line up, make sure that you left the X gantry nut block loose half a turn. If not, loosen them now. Everything should align quite easily and slide in. Again, tighten all 10 M5 screws down. Now let's move to the 90-degree connectors on the X-axis that we already installed. These will need to be loosened and slid to the end plates. Insert the M5 20mm screws and install the M5 lock nut on the other side of the plate. There are 4 in total on each end. Go ahead and repeat this on the other side of the X-axis. Over to the front of the machine, take 2 of your remaining 20x40 extrusions and slide them into the open C channel on the C-beam like we did for the X-axis. Now we can prepare the cross members. We need to slide 4 T-nuts into the top slot on both sides of the 20x40 extrusion for a 1010 machine. Once that is done, you can place them in between the L brackets we installed earlier. This can be a bit cumbersome, but it is possible to do this with the machine upright. For the sake of videoing and simplicity, I'm going to flip my machine over to show this. You're going to use 2 T-nuts for each L bracket. The L brackets will go one on each side of the middle 3 extrusions and then one on the inside of the 2 end extrusions. Leave the 2 end extrusions tight enough so they won't slip out, but loose enough so that you can reposition them. As for the middle 3, line these up with the markings we made earlier and tighten them down. I recommend using a square here to get them as square as possible. Now we can install our Y-axis end plates. Start by sliding 2 sliding T-nuts into the top and bottom of the front 20 by 40 extrusions. Then install the 4 M5 16mm screws into the bottom of the plate. Once they are loosely threaded, go ahead and install the 8 M5 20mm screws into the C-beam and the 20 by 40 you slid inside it. Once the plate is fastened, you can slide your ball screw into the bearing. If it does not want to line up, you might need to loosen the nut block screws on the Y plate a bit more. Over to the left hand side of the machine now, you can repeat the exact same steps. Now to the back of the machine, and again the exact same steps. It's important now to check the squareness of the machine. To do this, you need to measure diagonally across the machine. The 2 measurements should be the same. If they are not, then it's an indication that the machine is not squared. Go ahead and adjust the way the machine is sitting until these line up. Then you can tighten down all the Y-axis end plates to the 2040 extrusions on the front and back of the machine. Onto our Z-axis now. We can start by building our linear rails much the same way we did for X and Y. Thread 6 M4 40mm screws through each rail with an M4 sliding T-nut on each. Once this is done, grab your short C-beam and slide them on. Use your linear rail guide blocks to tighten one rail, and then tighten the end screws on the top rail to stop it from accidentally sliding out. Take 4 more of your linear bearings and slide them onto the rail, letting the retainers fall when the rail takes their position. Make sure that if you're using them, the grease nipples are facing outwards. We can now take our last ball screw nut housing and slide it over the ball screw, installing the 6 M5 50mm screws and tightening them. Now with the ball screw facing to the top of the plate, install the 4 M5 40mm screws, tightening them all the way down and then loosening them half a turn. Bring your Z-rail assembly back and align your bearings with the holes in the plate. Now place your spacer blocks on top of the bearings and set the Z assembly on top. You can now thread all 16 screws in and tighten them down. Once that is complete, loosen the one screw we tightened on the top rail, then move the plate as close to it as you can. Now work your way through the entire rail, tightening the screws closest to the bearings. Let's install our end plates. Start with the bottom end plate, which does not have the 4 tapped holes in it for the motor. Go ahead and place it on the bottom. Now install the 6 M5 15mm screws, leaving them a little bit loose. Once this is done, slide your ball screw into the bearing. Then tighten the screws down. We can now move to the other end. Place your end plate onto the ball screw and then install the remaining 6 M5 15mm screws. Wind the ball screw so the gantry is closest to the end plate. This will help with alignment. Now tighten the screws down. It's now time to install our C-clips. These go on each of the 4 ball screws at the non-motor side. If you don't have C-clip pliers, you can often get away with a small pair of needle nose pliers. Slide these over and make sure they snap into position. Repeat the same steps for the 2 Y-axis and the X-axis. Great, now it's time to mount our motors. Starting with the Z-axis before it's mounted to the machine, we need to install our square locking nut. Thread this on and tighten it against the bearing. It does not need to be too tight, so holding the ball screw with one hand should be sufficient. Once it is on, tighten the 2 set screws down to make sure that it stays in position. Now place a coupler over the ball screw shaft and load a 60mm screw through your motor and through a 9mm and then a 40mm spacer. You can now slide the motor shaft into the other end of the coupler and then thread the screw into the plate a couple of turns. Repeat this for the screw and spacer for each corner of the motor, and once they are all threaded, tighten them down. Now onto the motor coupler. This coupler only requires 2 set screws to be tightened down and you're good to go. Separate your motor wires and check for binding by turning the ball screw. Don't forget to tighten down your nut block screws the rest of the way. We can now go ahead and repeat the exact same steps on the X-axis and both Y-axis motors. Onto installing the Z-axis assembly. This can be quite heavy with the motor installed, so you might need to prop it up on something. Once you have it lined up, install the 4 M6 bolts into each corner and tighten them down. Now that the Z-axis is mounted, we can add our spindle or router mounting. I have an 80mm spindle which will be installed on this machine, but the process is the same regardless of the size. With the kit you will get 2 spindle mounts and hardware. Start by threading the M5 8mm screws through your 90° connectors into a drop-in T-nut. Then, using the M5 10mm screws, fasten it to the mount in the outermost holes. Once both are done, flip them over and repeat the same steps on the bottom side. Now we can place them in the Z-axis C-beam. Make sure when tightening that all of the drop-in T-nuts rotate. Tighten it down enough so that you can still move it